Hello and welcome back to Dr. Scott's Maths Made Simple. I've had a bit of a break, as we all do, a bit of a holiday, and I went home for my holiday, which is here, and we're going to talk about volume of water. I've got a cup. This is a cup. See this cup? And I'm going to, if I fill it with water, I want to know how much water I'm drinking. What do you think you would, how much water is in there, do you think, out there in YouTube land? Estimate. What do you reckon? Okay, well, thanks for your guesses. I'm going to work it out because we can use a bit of maths to do it. Okay, so there's my cup. That's not a very good drawing of a cup, but it's a cup. Trust me. I'm going to work out the volume in the cup of water. I'm also going to work out the volume of the water when it freezes. And because the volume changes of water, volume of water changes when it freezes, and most things, as you probably know, as they get colder, they get smaller, and when they get hotter, they expand. So when you've got railway tracks on a really hot day, sometimes they can buckle out because they get really hot, which is sometimes why trains derail, because of very hot temperatures. So that's because of the metal railway lines getting hotter and expanding, and then they're too long for where they are and they buckle out, left or right. But water is very strange. As water gets colder, it contracts slightly, but then when it gets to 4 degrees, it does a very strange thing. It starts to expand. And the volume of ice, if you had a block of ice like that, if that's water, it's that big, but when it becomes ice, it actually gets bigger, like that. It actually expands by 9%. And this happens at 4 degrees Celsius. So at 4 degrees Celsius, down to 0 degrees Celsius, ice expands by 9% volume. Of course, just by the way, the coldest temperature possible is minus 273.15 degrees Celsius, which equals 0 degrees Kelvin, which is a different thing. Human beings have never been able to get to 273.15, minus 273.15. But that's the coldest temperature that can be reached. Scientists have got very close to 0 degrees Kelvin, but they've never actually reached it. Anyway, that's by the way. So if I want to work out how much water I'm drinking, if I fill this cup to the brim, and let's just assume this cup is straight down. It actually goes in slightly, but we're going to pretend it's just completely straight down. So what I'm going to do is I'm going to measure. So first of all, I'm going to measure the distance across the top of the cup, the diameter, and it's 9 centimeters, roughly. So we'll just take it as 9 centimeters. I'm also going to measure the height of the cup. If we measure it down like that, it's about 8 centimeters. So we have a diameter of 9 centimeters. Across here, it's 9 centimeters. And we have a height of 8 centimeters. So I'm not sure if you know how to work out the volume of a cylinder, which is basically what it is, but I'll show you. So the volume of a cylinder equals pi r squared, which is the area of the top, just the area, times the height. So our diameter equals 9 centimeters. So it's 9 centimeters across, and our height equals 8 centimeters. So if our diameter equals 9, our radius equals half of that, which is 4.5 centimeters. So pi r squared is the area of the top times the height will give us the volume in cubic centimeters. This is in centimetres, that's in centimetres. We're going to end up with cubic centimetres. So that equals 3.14 times 4.5 squared times 8. Now I don't know if you remember, but 4.5 times 4.5 squared, I gave you a quick way of doing that. It's 4 times 5 and a 25 at the end. So that equals 3.14, just tell me if I'm going too fast, times 4 5s are 20.25 times 8. That is what the volume of this cup equals. Now, we can all do that on a calculator. We could do it longhand if we wanted to be boring, but we won't be boring. So I did it earlier, and I'll just tell you that the volume of water in that cup with a diameter of 9 centimetres and a height of 8 centimetres equals 508.7 cubic centimetres. So there's about just over half a litre of water in this cup. I wouldn't have thought it'd be half a litre, but apparently that's what it is. Right, okay, I'll just, if you look at Doggy for a moment, I'll just get my eraser. Got my eraser, okay. Right, so here's our cup. Now what would happen if we put this cup of water in the freezer and froze it? Well, remember, at 4 degrees Celsius, water starts to expand once it gets colder, which is a very odd thing. Most things get smaller, and it expands by 9% in volume. That's why they say when you see an iceberg in Antarctica, only about 10% of the iceberg is visible, because only 10% is sitting, or 9% is sitting above the water. The other 91% is sitting below the water. So, how would we work out how far above, if we put this in the freezer, how far above is the ice going to rise? Above the cup, above the lip of the cup at the top. How far is that distance? Well, one way of doing it, and there are many ways of doing it, but we know our total volume is 508.7 cubic centimetres. We know that's the volume of the cup when it's just normal water, but when we freeze it, it goes up 9%. So what you could do is multiply by 109 on 100. Now a good way to do this is just to cross off the 100 and take the decimal point back 2 places. So that equals 5.087 times 109. Everyone with me so far? Just call out if you're not. Okay. That actually equals 554.46. I did it on a calculator earlier, so 5.087 times 109 equals 554 centimetres cubed. So that's the volume of the water if we freeze it. So how far above the top of the cup has it come? Remember, if you put a bottle of water in the freezer when it's full, it's not a good idea because it can burst the glass. And this is why it happens, because water expands. So it's expanded by 554.46 minus 508.7. So you'll just have to take my word for it. It's expanded by, let's have a look, 45.76 centimetres cubed. So that's how much volume is above the top of the cup. So what we're trying to say is 45.76 cubic centimetres is above the lip of the cup. How far above the cup, the top of the cup, has it gone? Well, funny you should ask. Because we know the volume of this this cylinder on the top is 45.76. And we know that that equals pi r squared times h. Now we know everything here except h, just from there to there. How far above the cup has it gone? Well, 45.76 equals 3.14 times 4.5 squared, which is 20.25 times h. So if we divide everything by this, we get 45.76 divided by 3.14 times 20.25 equals h, which equals, believe it or not, 0.7 centimetres. So when we freeze this water, up it goes by 7 millimetres or 0.7 of a centimetre. So that's how much it goes above the top of the cup. As you see, the doggy's here learning maths as well, which is really good. Okay. Did you know that koalas rarely drink? They only drink if they're really desperate. But generally they get all their moisture from eucalyptus leaves. That's all the water they need. And they're one of the few animals that can digest eucalyptus leaves, which are actually quite noxious. Okay, that's enough from me. Thanks for listening. Like and subscribe if you wish. Thank you. Bye.